Alright, welcome back to my channel where math is made easy. So today we're going to be looking at systems of linear equation, and specifically how do we solve systems of linear equations using graphs. Alright, so this is a request and I'm going to put it out there. So let's go. But before we go, remember to like this video, share this video, and subscribe to the channel. And remember to put this notification button on so that when I drop a new video, you know that it's there. All right, and also remember to continue putting in where you're viewing from. Big up to the Cayman people. Yeah, I see somebody viewing from Cayman, so we're gonna go right into it now. Remember, systems of linear equations is just more than one equation, so two or more equations that have the same variables. All right, so example one, equation two, we would have touched on those already when we were looking at substitution by substitution. So this is just a refresher. How do we know if it's a solution or not? It must be true for both equations, so we'd have also touched on those. So I'll put the link for those videos in the description section. Now, how do we solve using the graph method? All right, so if we're using the graph method, your solution is where the two lines intersect, or in other words, where the two lines are meeting, where they are touching. Good, so that's one key thing to know. So the first step is that we're going to graph each of the equation on the same coordinate plane. The second step, estimate the point of intersection, and then thirdly, you check your point to see if it makes the equation true. All right, and then we'll know that that's our solution. So let's dive right into it. We're going to look at two simple examples today, just for that sake. All right, now when you're graphing the equations, you can use more than one method. You have what you call the table of values. You can go ahead and use that, or you can have it written in the slope intercept form and use that to find 2 points. All right, now I'm going to be using that form today because those are already written in the slope intercept form, so I'm going to use that. I do recommend, however, if you're going to be graphing it not using technology where you plug the 2 points in and it automatically gives you the two lines, I sometimes suggest that you use the table of values so that you get more than 2 points, sorry. But remember, all you need is 2 points to do the graph, really. But to make it more accurate, I suggest that you use a table of values so that you can get more than 2 points. But for this method, we're going to be using the slope intercept form. Now, what we must remember, the slope intercept form is y equals mx plus b. All right, now what's my b? That's my y-intercept. And my m is my slope. So for my Jamaican people, the gradient, and for my American people, the slope. And I think that in Jamaica we use y equals mx plus c. Now the same principle applies. All right, so we're going to look right here for our first equation. That's my m and that's my b. Now your y-intercept, what does that mean? It means that that is the point where your line is touching your y-axis. All right, so for my first equation, where's my y touching the y-axis? Where's my line touching the y-axis? It's touching it at 5. So 5 would be right here, right? So that's my first point. That's my first point. And then my gradient is telling me my next point. Now my m right there is a -2. It means that I'm going to be going down 2 times, and I like to write it as a fraction so that I can have my rise over run to get my second point. All right, so I'm coming down because it's negative 2, so that's 1, 2 down and 1 to the right. So my next point is going to be that, and I can make more points by coming 1, 2 down, 1 to the right, 1, 2 down, 1 to the right. And remember, as I said, you don't need more than 2 points. I'm just getting more points so that my line can be a little bit more accurate. All right, so I'm trying to ensure that trying to get the line straight. All right, so that's my first line, and I'm going to go ahead and label that as y equals minus 2x plus 5. Now let's go ahead and get our second line. My b right here, that's negative 1, and my m, so my second m is going to be 4, and again I'm writing it as a fraction. All right, so let's go. So that's b is negative 1, so it's touching my y-axis at negative 1, and my slope is a positive slope, so that's 1, 2, 3, 4 up, and I'm going across 1. All right, no, I don't even have to go further with my line. Oh, let's get it a little bit straighter because it's supposed to go through. But anyways, remember now your solution when you're graphing is where it intersects. So let's see if I can get, let's get another color. So my solution is gonna be right here. All right, so my solution would be, what point is this? That would be 1 and 3, right? So my solution, 1, 3. Good. Now let's test this point to ensure that it is a solution. So let's go ahead and test this point. Let's plug it in. So my x and my y. My y here is 3. Let me put it right here. 3, and my x is 1, right? So that's 3 is equal to negative 2 plus 5. So that's 3 is equal to, so that's 3 is equal to 3. Is that true? Yes, it is true. Let's put it in for this down here. So my y again is 3, and that's 4 times 1 because my x is 1. So that's 3 is equal to 4 minus 1. 3 is equal to 3. Again, that is true. Now, because it's true for both equations, then the point 1, 3 is indeed a solution for the system right there. All right, so that's very easy. I think that the graphing method is the easiest method to use because all you need to do is graph it, and then right away you'll see the solution. Now let's look at this one, and I'm just going to sketch the graph for this one because I'm just doing this example to show you if this is not in the slope intercept form, all you need to do is to rewrite it real quickly. So let's go. So that's 4x minus 4y equals 22. So this is in the standard form, but we can go ahead and rewrite it in the slope intercept form just so that we can graph it real quickly. So I want to eliminate my x to go over that side because we want to isolate my y. So I'm going to subtract 4x on both sides. So I'm left with negative 4y is equal to 22 minus 4x, right? And remember, we want y, so we're going to go ahead and do the inverse operation, which is to divide by negative 4y. Anything you do on one side, you do on the other side. Now that's cancelled, and this can be rewritten as negative 22, that's 22 over negative 4 minus 4x over negative 4. These two are going to be cancelled out. That's going to give me a plus. This is going to be y equals negative 5.5, and these two are going to become a plus. So that's going to be x. And I'm going to write it now in the slope form. So that's y. So let me put it now. Y equals x minus 5.5. So my two equations are going to be y equals x minus 5.5 and y equals minus 5.5. So we're going to go ahead and sketch this graph real quickly. So that's my x and that's my y. 1, 2, 3, 4, 5. So that's negative 1, 2. Alright, let's quickly go ahead and sketch it. So for my first one, my m is going to be 1, right? And my b is going to be negative 5.5. What does that mean? It's touching my y at negative 5.5. So negative 5.5 would be somewhere about here. Good? That's what that would mean. And then my m is going to be 1 over 1. So that's going up 1 and coming across 1. Right? So my line is going to look something like that. Nice? Now, let's move right here. Where do we find the line y is equal to negative 5.5? The line y is equal to negative 5.5 is going to be right here. So, again, where are they intersecting? Or where are they touching? They're touching at the point 0, negative 5.5. All right, that's the point that they're touching. So my solution is 0, negative 5.5. So let's do a quick recap. Remember, when graphing, the first thing to do is to graph both equations, and you can go ahead and plug these in and see if it's actually true. And if you test them, you'll see that it actually gives you the testing. So the first step, graph both equations. Second step, see where they are touching or where they meet or where they intersect, whatever word works for you. And then that is going to be your solution. You can go ahead and plug that solution in both equations just to test if it's true for the equations. And if it's true, then that is your solution. All right, let's plug it in right here. So that's negative 5.5, and then that's 0 minus negative minus 5.5. That's going to give me 5.5 is equal to negative 5.5. So that's true. Negative 5.5 for my y equals equals negative 5.5. Again, that's true. So the point 0, negative 5.5 is indeed a solution for this system. Now, I hope that this video would have helped you. Thank you so much for watching. I'll see you in the next video.